Hello everyone, let's graph some exponential functions, and we don't need a calculator for this. So first, let's talk about if a is bigger than 0, so it's a times b to the x. Exponential formulas are going to look like something like a base, and then you have a base of your exponent, and then to the x power. The x is always part of the exponent. That's what they call exponentials. So if a is positive, so you're starting with a positive amount, and b is positive, that's exponential growth. That means that you took, when you did the formula, 1 plus something, you got something that was positive, you made it bigger. So that's exponential growth. If it's a 1 minus, then you end up with a number less than 1. That's called exponential decay. B is referred to as the growth or decay factor. So an exponential growth problem is going to look something like this. An exponential decay is going to get smaller and smaller and smaller and look something like this. Okay, we're going to talk about analyzing those here in a second. So exponential growth. When we graph these exponentials, we graph a lot of functions the same way. You think of a parent function, and then you do translations on it. So this is a base 2 exponent, so what I'm going to do is pick some powers of 2. This is 2 to the x. Now, I'll start with 2 to the first is 2, 2 squared is 4, 2 cubed is 8. This is where it gets tricky. 2 to the 0, anything to the 0 power, except for 0, is 1. Now follow the pattern. Divided by 2, divided by 2, divided by 2. 1 divided by 2 is 1/2. And remember, 2 to the negative first is 1 over 2 to the first. This exponent is on the wrong side of the fraction bar. You move it to the bottom. Now he's happy and positive, so it's 1/2. That's my parent function. I'm actually going to draw it just to show you. Negative 1 is at 1/2. 0 is at 1. 1 is at 2. 2 is at 1, 2, 3, 4. And 3 is at 1, 2, 3, 4, 5, 6, 7, 8, right there. So it should look something like this. It gets pretty steep. And then the thing you need to realize is there is a horizontal asymptote. It will never get smaller than 0 because these decimals, these fractions, decimals, she's getting closer and closer to 0, but they'll never be 0. So that's what the function looks like. I'm going to do this while I'm thinking about it. Okay, and I'll put it back now. 0 was at 1. Okay, that's the parent function. What we're going to do is make a table with this translation. And remember, if it's x minus 3 on the inside of the parentheses, 2 to the power of x minus 3, that's going to make it go to the right 3. And on the outside, that's going to make it go down 3. This is just like we just did radicals. Same thing. So if you go right 3, you will only be changing x values. Going right 3 from negative 1, add 3, you're at 2. Going right 3 from 0, add 3, add 3, add 3, add 3. 2, 3, 4, oh, no, 3 plus 3 is 6. 2, 3, 4, 5, 6. I picked those so they should be nice. Down 3, all right, 1/2 minus 3 is negative 2.5. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 4 minus 3 is 1. And 8 minus 3 is 5. So if I look now, if I take this guy, this is at 0, 1, I'm going to go right 3, 1, 2, 3, and then down 3, 1, 2, 3. Right there is that the table that I just made. It looks like it's at 2, negative 2.5, yep. 3 is at negative 2, 4 is at negative 1, 5 is at 1, 6, see, I just moved it over. That translation gave me this new function. So we're just going to start with a parent function and then do a translation. So let's talk about domain. Remember, domain is left and right. As you go left and right, this thing goes forever to the left, so negative infinity, and forever to the right, positive infinity. It does take a while to get there, okay? It's going to slow down because it's going to get really, really steep, but it does keep going. It just takes a long time. The range is the y values. Now, because this thing had a horizontal asymptote at 0 and it moved down 3, the asymptote is y equals negative 3. It always follows the vertical shift. Right there is a horizontal asymptote at negative 3. It'll never get to negative 3. So what that tells us is that the range, the smallest y value is negative 3, and the biggest y value is infinity, and it never gets to either of those. So negative 3 is a parenthesis because it is not inclusive. It never gets to negative 3. And it goes to infinity, but you can't count to infinity, so that's always parentheses. That's pretty much it. Let's try another one. Also power of 2, so negative 1. This will be my parent function for powers of 2. 1, 2, 4, 8. Okay, so it's the same exact parent function I did right here. So x plus 2 is going to make it go left 2, and plus 1 on the outside is up 1. So left 2, from all of these, negative 1 minus 2 is negative 3. 0 minus 2 is negative 2, negative 1, 0, 1. Okay, so subtract 2. Add 1 to 1/2, and you get 1.5, 2, 3, 5, 9. Let's go ahead and draw it. 1, 2, 3 is at 1.5. Negative 2 is at 2. 1 and negative 1 is at 3. 0 is at 5. And 1 is at 9. So remember, the vertical shift was up 1. I'm going to draw that horizontal asymptote right there. Actually, do it in a different color. Right there. That's the asymptote. It doesn't go through that. But the actual function looks like, oops, it's not working. Looks like this. There we go. And then there is, it gets it really close to that asymptote. I just kind of use the horizontal line to help. There we go. Looks something like that. So because it went up 1, the asymptote is 1. And since it goes up, I know the range is 1 to infinity. The domain for all exponential functions is going to be all real numbers, which in interval notation is negative infinity to infinity. You don't have to think about it. It's always going to be that for these. All right, now this is a 1/2. So instead of a 2 to the x, I have 1/2 to the x. All right, this is going to be a little trickier, but we're actually going to do this. We're going to do negative 3, negative 2, negative 1, 0, and 1. Here's why. 1/2 to the first is 1. 1/2 to the first is 1/2. 1/2 to the 0 is 1. It's the same values, but we're going the other way. 1/2 to the negative first is 1 over 2 to the negative first, which moves to the top and becomes 2 to the first. This is 2. Look at the pattern. It just doubles. 4, 8. Okay, it's the same numbers, but we're going the other direction because the fraction needs to get flipped. And now in this problem, we're going to go left 3 and down 2. Left 3, negative 6, negative 5, negative 4, negative 3, negative 2. Those should be sequential because we picked them. Down 2, 8 minus 2 is 6, 4 minus 2 is 2, 0, negative 1. 1/2 minus 2 is negative 1.5. So I'm just using the translations to generate this table, and now let's see what this one looks like. Negative 6, 6 is right there. Negative 5, 2, negative 4, 0, negative 3, negative 1, negative 2, negative 1.5. Again, the vertical asymptote went, or the horizontal asymptote went down 2. So the asymptote, since it was a vertical shift of down 2, it's y equals negative 2 is the asymptote. So when you draw it, just keep that in mind. It's going to look like this. So this is a decay problem. And I know it's a decay problem because 1/2 is less than 1. Okay, so the range is 2 to infinity, negative 2 to infinity, and the domain is always negative infinity to infinity. So notice how this one's getting smaller. The first one gets bigger as you read left to right, but this one is getting smaller as we read left to right. See, it's decay, and that's what this graph shows, decay. So if that's less than 1, it's a decay problem. We'll do one more. This is a base 3, so I'll use these guys. I don't think I'm going to be able to fit them on the page, but 1/3, 1, 3, 9, 27. Okay? 3 to the negative first is 1 over 3 to the first, so 1/3. Now we're going to go right 1 and up 1. So to go right 1, up 1, add 1 to all these guys. 0, 1, 2, 3, 4. Add 1 to all those. 1.3, 2, 4, 10, and I'm not going to fit that on there, but 28. So since it went up 1, I'll draw the horizontal asymptote at 1, just so I have it there, so I don't draw anything below that. 0 is at 1.3, right about there. 1's at 2, 2's at 4, 3's at 10, right there. Okay, so it looks something like this. So it kind of has a little bit more steepness to it, but it's very tough to tell because it's such a small graph. The asymptote is y equals 1, which means the range is 1 to infinity, and the domain for all of these is negative infinity to infinity. So that is exponential graphing. Go ahead, try the practice, and make sure you hit that like and subscribe.